and start the stream. All right. So no real announcements. We're more than likely gonna wrap up section 1.6 today. We'll probably take this Friday as a problem session, as a homework session. So like it helps if you come with questions, so it's just not so much dead time. Otherwise, I'll probably just choose questions at random. Let's go ahead and take the time today to finish out this lecture with whatever time we have remaining. We'll let's go like this. I forgot about the chat. With whatever time we have remaining, we'll let me see. Go like this. Like this. And again, that was. Okay. Let me see. Let me see my audio. Can you hear me? Yeah, I was letting someone in. Can you guys hear me? You should be able to hear me. Okay. Can you guys hear me? Okay. So yeah, we'll finish out chapter 1 today. With whatever time we have remaining, we can like use that time to kind of answer questions either from the homework or just anything in general. Tomorrow on Friday, we will more than likely we'll just work. I'll probably go through the homework, right? So that session will serve you the best if you come with questions. Also, let's be sure that we're all doing our Alex, right? Everybody should be doing at least 25 topics per week, and then it's adjusted if you're in any of the other two categories. And then next week on Wednesday, we can anticipate exam 2 to open up. Give me just a moment. Okay. So let's just go ahead and take. Oh, I gotta close this out again for it to work properly. Nope, not that one. Not that one. This one. Okay. So yeah, let's take the time to go ahead. I don't think we have that many slides that we need to do today, but let's just kind of keep working. So far with this section, we've been talking about arithmetic operations on. All right, what time is it? 37. Yeah, every time you guys come in late. Let me do it over here. Oh, he's already. I think I took his attendance already. I think he just may have gotten booted back. So yeah, we were doing arithmetic operations on functions, right? So adding, subtracting, multiplying, and dividing functions. And I think last time we introduced this notion of composition of functions, right? So we're going to continue. Composition of functions is basically a function within another function. So we're going to continue that discussion here. Let me add a page here. Okay, and like this. Okay. So in this example, we're given f and g, and we're asked to find f compose g of x and its domain, and then the reverse in its domain. Okay. So let's see again. We have f of x equals x plus 1, and g of x equals 1 over x. Right? So then question A asks us to find f compose g of x and the domain, and its domain. Okay. So what we're introducing today is this notion of how to find the domain of a composite function. There's a 3-step process there that I use that seems to work. We'll explore that momentarily. All right, so let's focus on this f compose g of x. Again, what does this mean? This means the second function inside the first function. All right, so g of x inside of f of x. Right? If we keep going, well, what's our g of x? G of x is 1 over x. All right? So then what we're going to do is just rewrite f of x, but replace each x with the green thing. All right, so we're going to have x plus 1, and the green thing in this case is going to be 1 over x. Okay. So this is going to be f compose g, the g inside of f, right? Okay. So then there's a 3-step process that I do to find the domain of a composite function. So then to find the domain of a composite function, I do the following. The first thing is I find the domain of the inside function. Find the domain of the inside function. So in this case, the inside function is g of x. And so that's going to be this thing here, 1 over x, right? So this is a rational function. For a rational function, the domain is generally all reals except any x that makes the denominator 0. So we're finding the domain of g of x. Right? Again, so in general, the domain of a rational function is all reals except any x that makes the denominator 0. So in this case, that'll be everything except 0. So the domain there is everything except 0. The second step that I do for finding the domain of a composite function is find the domain of the simplified function. So in this case, that's going to be, I guess I'll do this, the domain of f. Okay, so then if we look here, the only restriction is, again, we just can't divide by 0. Right? And so that one just happens to be the same set. X is not equal to 0. Okay, so then the third step is take the intersection of those two sets we just found. Okay, intersection is basically what are the two sets that have in common? What points do they share, right? The first set is everything except 0. The second set is everything except 0. So basically, everything except 0 intersect everything except 0. Those are actually the same two sets, so then that result ends up being, again, just everything except 0. And if we're going to write that in interval notation, so say here's our 0. Oh. Say here's our 0, right? And we want everything except 0. So we want everything to the left of 0. We also want everything to the right. everything to the right of 0. And then if we want everything except 0, we need to group it with parentheses in this case. Right? So that's the graph. So then if we write this in interval notation, the far left is going to be negative infinity up until 0. And then we're going to go from 0 to infinity. Infinity always gets a parentheses. In this case, because we don't want 0, that also gets a parentheses. And then we're going to combine these two sets with union, right? So the union just means the solution can come from any point in the left set or any point in the right set, right? Just basically combine it. The solution to set is going to be a combination of these two sets, right? Okay, let's work another one. If you have questions, I am monitoring the chat. Let's just try another one, and hopefully that'll help clear up a lot of that confusion, if there is any. Okay. Oh, and then we need to do B. So, here, let me get a copy of these guys. So then B asks us to do G compose F of X, right? So we basically just reverse the order. We just reverse the order, right? Again, what does this mean? This means G of F of X. So now F of X is our inside function. Okay? So this is going to be G of F of X is X plus 1. Okay? So then what we're going to do, we're going to rewrite G of X and replace all the X's with the red thing. So then the final result is going to be 1 over X plus 1. Okay? Why are you making vinegar? So fast. She was behind me. She's so fast. Like I can never tell what she is. Okay. Oh, so then the domain, right? Let's just add a page. And keep in mind, all the stuff that you see me writing, I make it available on our Blackboard page. If you log into our Blackboard page and go to folder number 7 where it says box, that's where I load all of these notes. You should find a copy of each of these notes. Okay, so then to find the domain of this, again, the first step that we do, we want to find the domain of the inside function. In this case, the inside function is this f of x equals x plus 1. So that's a polynomial. The domain of a polynomial is all reals. So in this case, it's going to be the domain of f. And that domain, because it's a polynomial, the domain ends up being all reals. Okay. The second is find the domain of the simplified function. The simplified function in this case is going to be this guy here. So this is a rational function. The only restriction here is that we cannot divide by 0. So we'd have to throw out x equals -1, right? So then the domain of the simplified function. In this case, it's going to be everything except -1. If we're writing that in interval notation, we want the whole number line except -1. So we're going to go from all the far left is going to go from -infinity up to -1. Then we're going to go from -1 to infinity. Infinity always gets a parenthesis symbol. In this case, the -1 gets parentheses, and we combine it with the union. It's kind of the same argument as the one we did a few minutes ago. Okay, so then the third step is we take the intersection of these two sets, right? So the third thing is to take the intersection of these guys. Okay? So if the first set is the whole real line, the second set is everything except -1. What do these two sets have in common? Basically the blue, right? So if we said the whole real line intersection the second set, which is everything except -1, that ends up being just the blue part. Okay? So we got the yeah, 1 over x plus 1, and the domain was everything except 0. This one was 1 over x plus 1 in this fashion, and this domain was everything except -1. So far what we've been doing, given two different functions, if we said one function compose another, we would get an answer. So with this example, what we're going to do is we're going to start with the answer and work backwards. See, can we decompose this function into two functions so that now when we say f compose g, we finish with this result that you see shown, right? So there are multiple correct answers here. I'm just going to show one correct answer. So it kind of helps if you think about, okay, what could be a potential inside function? So we're going to say let g of x, we can do like 2x squared plus 1. Again, there are several correct results here. So then we're going to say let f of x is going to be 1 over the square root of x. All right? So then if we said f compose g, if we put g inside of f, then we should get h. Yeah, I don't know. I got sleepy all of a sudden. Mr. Downs, are you talking about this example or the previous example? Because we're not going to do a domain here. I mean, if we wanted to do domain, if we did f compose g, right? If we were going to find domain here, even though it didn't ask us to, if we found the domain of f compose g, right? The inside function in this case would be this guy. So that's a polynomial. The domain of a polynomial is all real. So the domain of g will be all reals. And then the simplified function will be this guy. All right, let me clear out some of these scribbles. So this would be the simplified function, right? So we have a couple of restrictions here. First is that it's a rational function, so we can't divide by 0. And then there's a second stipulation is that we're taking the square root, so we can't take the square root of a negative, right? So if we were going to find the domain of that simplified, normally the radicand being this 2x squared plus 1, normally it would be greater than or equal to 0. But because it's in the denominator, it can't be equal to 0, right? So it would have to be strictly greater than 0. Then if we solve, subtract, and divide, we get x squared is greater than negative 1/2. Take the square root. Square root is imaginary, right? So not a real result. Okay, so this should be, I want to say this domain will be all reals. Let me think about it. If we subtract, divide, take the square root. Yeah, so like, look, right here, the reason I'm pausing, because this guy here, right? If we, the numbers that we're going to consider, right? Say we look at a positive number, right? We square a positive number, it's going to say positive. Ultimately, all positives are going to say positive, which are greater than 0, right? Then if we think about 0, like if x were 0, it would still be greater than 0. And if we think about negatives, if we square a negative, it becomes positive, then we're back to the first case. And so no matter what real number we put in here, it's going to be always be greater than 0. Um, my claim would be that this domain is just going to be all reals, right? The inside function was all reals. This one, no matter what real number we put in, is going to be positive, so that's going to be all reals. So then the intersection of those two sets would be all reals. Okay. But again, like this one, they didn't ask us to find the domain. But again, to find the domain of a composite function, again, what we do is first we find the domain of the inside function, and that takes practice. Right? That just takes exposure. Just keep working with it. Eventually, it starts to click. First, we find the domain of the inside function. Then we find the domain of the simplified function. Then we take the intersection. Okay. Let me come over here. Let's just try another one. So yeah, what they decided, I think they did the same route that we did. They said let g of x be 2x squared plus 1. And then f of x was going to be 1 over the square root of x. So then you can see, if we do f compose g, we finish with h. Right? Let me see the time. So in this example, it says calculating the area of an oil spill from a tanker. Oil is spilled from a tanker into the Pacific Ocean, and the area of the oil spill is a perfect circle. It says the radius of this oil slick increases at a rate of 2 miles per hour. Okay. Express the area of the oil slick as a function of time, and then calculate the area covered by the oil slick in 6 hours, right? So we have the area as a function of the radius. Um, it also tells us that the radius increases at a rate of 2 miles per hour. All right. So it tells us that the radius is going to be 2t basically, right? Where t is like an hour. So after 1 hour, it'll go what 2 miles. After 2 hours, it'll be 4 miles, so on and so on, right? So we express the radius as a function of time. So if we want the area as a function of time, so again, this is going to be our radius as a function of time, right? So then if we said the area a of r of t, that'll give us the area expressed as the function of time. Because right now the area is expressed as a function of the radius, the rate. And then we can express the rate as a function of time. So then ultimately we can express the area as a function of time. All right. So then this would be a of 2t. That's going to be pi times 2t squared. That's ultimately 4 pi t squared, right? So then after 6 hours, 36 times 4, 120, 144? 144 pi, okay? So we can see a type version, okay? So if we get the 144 pi, we just crunch the number to get the final result. Let's just try one more. We have one more example, and then we can kind of open the floor. Right? Okay. So I'm going to get everybody started on this one. Then I think we're going to try a breakout. We're going to try a breakout group with this one. Breakout rooms, right? So it's probably a good idea to screenshot this slide. Okay, it's probably a good idea to go ahead and screenshot it. It says a car dealer offers an 8% discount on the manufacturer's suggested retail price (MSRP) of X dollars for any new car on its lot. At the same time, the manufacturer offers a $4,000 rebate for each purchase of a car. Write a function R of X that represents the price after the rebate. Write a function D of X that represents the price after the dealer's discount. Write the function R compose D of X and decompose R of X, and then interpret what does it mean. And then calculate D of R minus R of D and interpret what this means. Okay. So let me kind of help you get started. So it says write a function that represents the price after the rebate. So it says the rebate, a $4,000 rebate, right? So whatever the price of the car is, you can take $4,000 off, right? So then R of X in this case is going to be X minus 4,000, right? That's the price of the car after the manufacturer's rebate. And then we want the price of the car based on the dealer's discount. So then D of X, it says 8% discount, right? So instead of paying 100%, we can take 8% off of 100%. That leaves us with 92% of the price of each car. Okay? So I went on and gave you R of X. I went on and gave you D of X. Hopefully you have a screenshot of this slide as you see it. And we're going to break out into breakout rooms. Okay? Let me see how many participants we have. All right, let's see. We're going to do some breakout rooms. I have to hop over here. 20 participants. 5 groups of 5 sounds good. Okay, let me think about it. Yeah, we'll do 5 groups of 5. So we'll create some breakout rooms. And then the options, I want you guys to take, let me see. We go, I think we're going to 505, so 455. So if I wanted to go to about 450, 445, 20 minutes, right? I'll give you about 20 minutes. Let's say 20 minutes and see how you can do with this one. Notify when the time is up. This looks good. And we're going to open up the rooms. Okay. Let me give them some time to think about it. Oh. Hey Siri, set a timer for 5 minutes.
Okay, your timer is set for 5 minutes.
All right, guys, how's it going here? Oh, let me see something. Like this. So how's it going? Did you have any questions, or how's it looking for you?
Yeah, I actually have a question. Which question? I mean, which letter are we supposed to do?
All of them.
All of them? Okay.
Yeah.
Hey, can we see it real quick? Can I see it?
You need to see it again?
Yeah.
All right, let's do like this. Share.
Okay. All right, one. I just need CD.
Okay. Let's hop over. Okay. Let me just kind of hop around. All right, guys. How's this looking for you? Did you have any questions, or did you want to ask any questions? Let me see. You should be able to unmute yourself. Yeah.
I'm good.
You're okay?
I think we got it.
Okay. All right, I'm going to hop over to the next room if you don't have any questions. All right. Hey guys, how's it going? Did you want to ask any questions? What we're doing here?
Professor, are we doing the whole problem set?
Yeah, the whole thing.
Okay.
Yeah.
Yo, I mean, like I attempted to do it. I don't know if I did it right, but
Okay, so I think I did A and B for you, right? Like I gave you those.
yeah.
So then C is just like so when it says R compose D, right? R O D of X. That means D of X inside of R of X, right?
Yeah, so it would be 0.92x minus, but like in the parentheses, right? Or nah? Because let me go back to.
I think okay. So I would say practice going with your first mind. Because if you practice going with your first mind, eventually it'll become more and more accurate. If you practice second guessing yourself, eventually what you're going to start doing is second guessing yourself out of the correct answer. So whatever your first mind says, just go with it. You'll be okay in the long run. But what
so you know, it says like first it says R of the dx, right?
Mm-hmm.
So that means for that one we put in D into R, right?
Right. D is inside of R. So, the second function inside the first function.
So the equation for R is x minus 4,000, right?
Yep.
So then we would put 0.92x in the parentheses minus 4,000, right?
Okay, sounds good.
And then for the D of R, it will be 0.92 parentheses x minus 4,000.
So let me see. You're doing R inside of D. Say that again.
No, D inside of R. I mean R inside of D. Yeah, R inside of D. It will be 0.92, right? Parentheses x minus 4,000.
Yeah.
So then when we go to solve it,
I think it sounds like you're pretty much there. Just think about it, and we'll look at it in a few minutes together. Yeah, you're pretty much there though. Okay. All right, guys, how you doing here? You okay? Did y'all want to ask any questions?
Oh, go ahead. I'm sorry. I was actually kind of working on the homework.
Okay.
My fault. I have the problem.
So I would say just maybe take a few more minutes on it, and we'll come back together and we'll go ahead and finish it out together. Um, so we'll come back together in a few minutes if there aren't any burning questions. Let me hop over to the next room. All right, guys. Did you have any questions? How is this working out for you?
Uh, for me so far, I just got the C, and for R of D of X, I got parentheses 0.92 X close parentheses squared minus 4,000. So I was trying to, I might be wrong.
Okay, it's okay. So I'm gonna share with you the same thing I shared with another group. Practice going with your first mind. It might not be right initially, but the more you practice going with your first mind, over time it'll become more accurate. But if you constantly practice second guessing yourself, eventually what's going to happen is you're going to second guess yourself out of the correct answer.
Yeah.
Right. So okay. Again, the composition all it means is the second function inside the first, and the thing that I would suggest is whenever you do a substitution, like if you're replacing x with anything, before you replace the x, the first thing is replace the x with a blank set of parentheses.
Yeah, that's
right?
what I. Oh wait.
Yeah,
So
yeah. Replace the x with a blank set of parentheses, and then put the thing inside the parentheses, and that'll help with the distributing and keeping track of negatives and all that kind of stuff. Right.
yeah.
So the x with the blank parentheses, then put your substitution into the blank parentheses, and that'll clear a lot of that up.
All right.
Okay. All right. So let's just take a few more
Yes, sir.
minutes, and we'll come back together as a class and finish this out.
All right.
Mm-hmm. All right. I'm gonna let them work that out. Let me see the time. Where's my timer? Hey Siri, set a timer for 7 minutes.
Okay, 7 minutes and counting.
That's what needs to happen, honestly. Because once I start paying rent, like I don't see one. I don't even know that I can pay rent right now because I'm still paying on one of those debts on a month to month. So it's like, I would get busy. Okay, is that everybody? Nope. Okay. I think we still got a couple more. Okay. Let's go back to here. This one. Share. All right. So let's see how do we do. Okay, that one is a little bit. It's a little bit involved. I wanted you to think about it. So let's just look at and see how do we do. Oh. Okay. So yeah, let's see how do we do. That one was a little bit involved. Let's go like this. One more time. Thank you for the heads up about the mute. Okay. So again, so kind of looking at it. So we did A and B together. Oh, are you acting up now? You are acting up. Okay. So after the rebate, right? So we take the price of each car minus the $4,000 rebate, and then B was a dealer discount, 8% off. So instead of paying 100%, we paid 92%. So then if we do R compose D, that means D is inside of R. Ultimately, we should get 0.92x. So let's write it like this. R compose D of x. So D is inside of R. That's going to be 0.92x minus 4,000. And then decompose R of x. So R is inside of D. That's going to be 92 times x minus 4,000. Right? I know it's a little bit cramped. Right? So those, we have it typed up here. So here's A and B. X minus 4,000, 92% of the price. Then for C, R composed D ends up being 0.92, R of 0.92x. So you see the result here. You see the result here. Right? And then decompose R, which means this guy's inside of the D of x. So then 92%, see the parentheses here. Right? We distribute to simplify, and we get something like this. Okay. So then I think question D asks us to do D compose R minus R compose D. So then basically, what is this? The second result minus the first result, and we get this 320, right? I think when we do decompose R, we apply the rebate first and then the dealer's discount. So the rebate was applied first. So what this means is that if we apply the rebate first versus applying the dealer discount first, it's going to cost us $320 more per car, right? The equation shows that it'll cost $320 more for any car, regardless of the price, if we apply the rebate first and then the discount, right? So it sounds like it'd be more favorable to us to do the dealer discount first and then do the rebate, right? Okay. So let me see. Yeah, with the parentheses, right? I figured that might be a little bit of a challenge. So when we're doing substitutions, the recommendation is like if you're going to replace x with anything, first replace x with a blank set of parentheses, right? First replace x with a blank set of parentheses. Then whatever you're substituting in, put it inside the blank parentheses. That'll help us to keep track of negatives, and it'll kind of show us if we need to do distributing or anything of that nature, right? Also, I'd like to encourage you to practice going with your first mind. Initially, your first mind, it may or may not be correct, but in the long and over the long term, your first mind will become more accurate. But if we always practice second guessing ourselves, eventually what happens in the long run is that we second guess ourselves out of the correct answer, right? So I just didn't want you to practice second guessing yourself. I'd rather you practice going with your first mind. Honestly, I mean, okay. Normally, I let you go about 4:55. Um, we'll go ahead. We'll go ahead now. I'll kind of be on the call a little bit longer. Like, let me go ahead and share these. I'll be on the call a little bit longer if anybody want to ask any specific questions. Matter of fact, let me go ahead and do this. But otherwise, we'll take all of Friday to kind of work through the homework as best we can for this section. Also, we want to be ready for exam 2 over the second half of chapter 1 next week. If you don't have any burning questions right now, you're free to leave, and I'll just kind of be around if anybody would like to ask any questions. Let me go ahead and load a copy of these notes in Box so you guys can access it. This one, notes, right there. Okay. All right, guys.
All right, Professor. See you tomorrow. Stay up.
Yep. Take care. But it wouldn't open. Did you get like an error message? It should be a PDF, like a document that you should be able to open.
Like I clicked on it, and it's like it like downloads, and then I click on it to like open it, but it doesn't open. It just like stays there. Like, I don't even know how to explain it.
What kind of device? What kind of device are you working on?
A MacBook Air.
Yeah, because I'm working on an Apple device. You should be able to download it. Or you might be able to just open it, like double click to open it. Was it all of them or just the latest one?
It's all of them. I did the latest one. It didn't work. Then I just did week 6. It's not opening either.
Are you getting any kind of error message?
Oh wait. I got it. Okay, I got it. I think.
It should be.
Yeah. Okay, I got.
Yeah,
I got last week's. Is the other one like? It's not up yet.
No, it should be. It should be a PDF. Like these should all be PDFs. Yeah.
All right. Thank you.
Okay. Yeah. No worries. Yep. Take care. Okay, guys, if there aren't any burning questions, I'm going to let everyone go, and I'll see you guys tomorrow, 4 o'clock.